I would argue that your sine and your cosine graphs, Tom, thanks, are pretty much, they're really closely linked. And in fact, who would like to tell me how they are linked? It's a translation over by pi on 2 / 90 degrees. Now, just be careful when you're writing stuff down. This is the one thing I want to make sure that you're aware of. So notice that this, how it's written like this, is different to this. Can you see where the brackets are? Ladies at the back, this is important. Please look. So this is different to this. Okay, and you might go, what's the big deal? You got the B's, you got the C's. When it is written like this, the period of the function, right, is going to be right, or, well, basically, yep, so 2 pi on B, but, well, I'll take that back again. We'll talk about the translation. So your horizontal translation for this one will be C. Would you agree? So it'll be C, and in this case, if C is positive, it will be to the left. Do we agree? And what is your horizontal translation here? Still C? No, it is not, because of where your brackets are situated. So this is where you do have to be really careful. So here, your horizontal translation, will it shock you to discover that it would be C on B? Right? Because if I was to rewrite this, is this the same thing? Sine B x plus C on B. Check that. How do you check it? Just by expanding. B times x, you get the bx. B times C over B, you get the C. So you've got to be really careful when you're writing that down, and there will be questions, I hope, where they ask you, state the horizontal translation. So when you've got that B pulled out as a common factor, really easy. Bang, that's your horizontal translation. That's in the bracket. But when you've got the common factor, there's not a common factor out there, then your horizontal translation is C over B. So again, if you want to make a note of that on your notes page, I would strongly suggest that you do so. The other thing that we should know by now is that A affects the amplitude. They can't see my pointer on the video at home if I just point without the thing. We know that B, yes, is our period. C is our, we talked about that, horizontal translation and vertical translation. Which one changes for sine and cosine? Which is the one that's different? I would say it's the B when it is negative, because when you've got negative cosine, right, cos of negative theta, that's the same as cos theta. So that's not going to change the graph at all. But when I look at, how about y equals sine 2x compared to sine negative 2x, what does that happen? What does that graph look like? So that's going to, excellent, it's going to be reflected in your x-axis. And what else does the 2 do? Right, so it squishes. You're going to get 2 graphs in the space of 0 to 2 pi, like normally. One sine graph takes 0 to 2 pi to complete. Do we agree? But this time we'll have 2, and absolutely, how can you easily say that its period is going to be pi? Because we know that period is 2 pi over b. So when I've got this in front, it's 2 pi on b, on 2, which is just pi. So we're getting all of that stuff pulled in together. Do we agree? So soon, people are asking, what do we do now? I'm very aware that, you know, we've got a long weekend coming on Monday. Well, you've got the day off on Monday. However, Monday week, you have a test. We've still got a couple of things that we want to do, and we've got to use our graphics calculators for some of it. So the bit that we need to finish off with is, yes, we're playing with the sine graph, the cosine graph, and you'll see in your books, if you scroll, you then have to look at your tan graph. So we want to try and do that, but we're going to do that pretty quickly today. And then we want to look at how do we solve trig equations. So before we get to that, are there some requests from the homework that we had? When we look at this graph, we straight away know or notice what? It has just dropped. Would you agree? It's just dropped all the way down. So how far has it dropped? It's gone from, where would it normally start? Right, it would normally start at 0, and it's gone down by, clearly, 2. So next thing we check, has its period changed? No. Has its amplitude changed at all? No. So one of the things that, again, back to your notes page, please, can you add a little name that this D, this has got a special name. It's called the principal axis. Anyone want to have an idea why it's called the principal axis?
Is it where the center of the graph is supposed to sit?
Yeah, it's where it goes straight through the graph, and, you know, that's where it's all even around. I like what you just said there, the center of the graph goes where it sits. So, principal axis. All right, so we can see that's beautiful. Here it was 0, now it's at 2, so it's dropped minus 2. The amplitude is the same, so we can confidently say that that one is just sine x. Hasn't shifted left or right, but it's dropped down by 2. We happy with that? Simples. So, who would like to talk us through B? So, what's my principal axis at this point? You can see it's going straight through. It's the x-axis, so has it moved up, has it moved down? Not at all. So I already know D is just diddly squat. 0. My friend. Yes, Karen? Ooh, is there? 1, 2, 3. So I would say there's 3 cycles, but absolutely, you notice they're squishy, and yes, you saw as soon as you said 2, you went, ah. So, yep, and the amplitude is the same. If I had changed it, so we're going to go with that's y equals sine 3x and no plus or minus anything. Agreed? If this was, let's change that to, what shall we change that to? 4? If that was 4, and then that would have to be minus 4, then that would be a simple case if it would just be 4 sine 3x. Agreed? What would you tell me this graph is? Hang on. So it's going down first. So it could be negative 4 sine 3x. There's actually one more it could be. Anyone know? Oh, who said that? I can't see. I threw them up. Oh, well done. Or y equals 4 sine negative 3x, right? It flips it. When you've got a minus at the front, that flips it. And when you've got a minus in front of here, that flips it. So it's the reverse. So having said that, couldn't we actually say, I mean, and you wouldn't do this in normal life because it's just a bit silly, but would you agree this would also be minus sine minus 3x? That flips it, so it then makes it go down, and then that flips it again. But we're saying that's a bit silly. But just know there's more than one way to write these equations. Happy with that? Okay, have a look at C. Ooh, what's the first thing we notice there? It's not actually, it's not actually starting. It's not starting where we want it to, is it? What's it done? You could say it's moved left by how much? Pi on 2, right? So it's moved to the left by pi on 2, right? So what can we say? Is the amplitude the same? So it's still 1, so therefore it's just going to be 1 sine. It hasn't actually moved up or down. It hasn't got squishy because it's still 1 cycle. So we've got sine it's moved left, good. So it's pi on 2. And what do you also, I better get rid of that. So it's the green one, not the, I just drew that to make sure you realise what's going on there. But what else is that graph? Starts at the top, goes down. That is also what graph? Cosine graph. But they've asked you to write it as a sine graph, so we're going sine. Okay? Correct. And again, what if we went, so if we've got our, I shouldn't do it in the same colour, so let's go purple. Green. No, that's green. Orange. Orange. So there's our original. Oh, come on. Never mind. What's the gap from there to there? That's pi on 2. 3 pi on 2. So could we also say it could also be y equals sine. So you're moving to the right by 3 pi on 2. What would that be? Yeah, negative. So x take. Yeah? So again, there's not just one way to write these things. What do we want to try and do? We want to try and use the smallest value possible, right? But if you were doing this in an assignment, worksheet, test, whatever, and one of you had this and one of you had this, all good, right? Different equations, same graph.
Would you also display it with the plus or minus symbol in there instead?
Plus or minus symbol where, my friend? The question was, would you also put it here? Yeah. Who could answer that? So could I have plus or minus here and plus or minus here? No, because if you look at it, this minus, that would be you're moving it just pi on 2. So my graph here, you're moving it just pi on 2, so I'd go there. So that becomes a very different graph, okay? So, no. Oops, what have I done? Okay, so any other questions with that? I think hopefully that gives you the heads in. You can have a look at those. You've got the equations at the back. You can sort of work a little bit backwards if you need to. We okay with that? So cosine was pretty much the same. And if you got stuck on those graphs, hopefully that might have helped you a little bit, but you can come back and you get time soon when I shut up. Were there any issues with this bit, or we haven't had a chance to get to it yet? Haven't had a chance to get to? Okay, so I'll let you have a little. Who's finished it all? Love it. So this is 7C. You're doing exactly the same thing that we did with sine. You're just doing it with cosine, right? Get used to being able to sketch that graph. We need to know them and love them beautifully. Now, if you have finished, you are going on and you're looking at the tan graph. And for those who have to finish 7C, you've got a choice. You could do the tan graph now if you wanted to, or you could do 7C and do this later. There's 2 major differences, maybe 3, between the sine and cosine and tan graph. So I've lost track of. Notice, why have we got these things here? Do we remember what these were called? I talked about it in class. Starts with an A. No, right, they're called asymptotes. And I'll write that down. So we want to look at our tan graph now. And I don't know if you remember back to when we were looking at the unit circle and it went bazinga, right? We're all crazy. This is how we look at our tan graph. Now, these things here, dotted line, that is called an asymptote. And what that means is along those dotted lines, the function does not exist. It is undefined. Okay? And we've got one here, and then we will also have one here. And then our tan graph basically looks like this. It's a nice little wave, and it's sort of, or curvy thing, and it's going to keep on going. And then over here it sort of goes, and then that's not very nice. We'll do that. Okay. Why do these asymptotes exist at this and this specifically? Pardon? Tan never intercepts. Why? Yeah, why do they not intercept at pi on 2? Pardon? No. Yep. Oh, sorry. You've got to be very careful to flick the pen. So, how, I guess I could reword it. How are sine, cosine and tangent connected? Hamish knows. Yes. You can't divide by 0. So remember, tan is sine theta over cos theta. And that's why I drew our cosine graph, because we can clearly see that at pi on 2 and 3 pi on 2, your cosine is 0, and we cannot divide by 0. Okay, so first major difference. 1, we've got asymptotes with a tan graph. Second, what is the period of your tan graph? So how long does it take to complete one cycle? Sevi? How long does it take to complete one cycle? This is one cycle, this is one cycle, this is one cycle, because then it repeats itself, yeah? From pi on 2 to 3 pi on 2. What's that gap? Is that properly? Poi. Right, so the next thing that we want to make sure that we know is that the period of tan, it's not 2 pi, it is pi. But the same rules apply when we go, pi over b. So instead of pi over 2b, it's going to be pi over b. So, right, are you writing that on your summary? And the other thing is the amplitude. What would you say is the amplitude of our tan graph? So for sine, the amplitude was the value in front, A, right? Same with cosine graph, it was A. What's the amplitude of tan? It's undefined, right? It just keeps on going forever and ever. In this case, we're not saying that it's doesn't exist, right? So here, when we're looking at our asymptotes, we're talking undefined, doesn't exist. When we're talking about the amplitude, we could say it's infinite, really, right? It's undefined because it can just keep on going and going and going. Everything else, the same thing that we did with the sine and cosine, right? The plus c, we'll move it left and right. The plus d, we'll move it up and down. Same. Oui? The same way to find the b or find the period. Just make sure that you're using pi, not 2 pi. All right? So can I give you 15 minutes to play around with C and then go on to the tan? Oops, sorry, I'll pop that back in a minute. Okay, so they're going to ask you to do your little sketching. Did someone just say, what do we write down? So we went probably a little bit longer than I anticipated. That's okay. We've only got 2 major things to do, and one of them will only take 10 minutes. Get that knocked off. I reckon we'll knock it off tomorrow. And so you can practice over the weekend, and we'll be ready for our test week 8, Monday. Now, homework. I really need you to make sure that you have got your graphs and you're comfortable with them under control, being able to sketch, knowing the max and the min. We're just talking up the back. Hey, I've got 2 minutes there. We were just talking up the back. When you had something like y equals sine x, what is my max and my min? 1 and minus 1, because it oscillates between 1 and minus 1. So then when I've got 4 sine x, what is my max and my min? 4 and minus 4. What if I went minus 4 sine x? What's my max and my min? 4 and minus 4. What if I went y equals minus 4 sine x plus 2? What is my max and my min? So this is lifting it up. So 6 and minus 2. Hang on. What if I now had, this is the last bit, what if I now had sine 3x take pi on 2 plus 2? What's my max and my min? And I can see Tom's going, big eyes. How am I meant to work that out? Well, it's the same, because this just shifts it left and right. Doesn't change the max and min. This, this switches it. Doesn't change the max and min. So this will still be 6 and minus 2. I'll repeat that again. I tend to repeat things over and over so we get it. You may